Hello again, I am Emilio and now I will present the final experiments designs for my project Drum Boiler Optimization Parameters and the results obtained. Follow me through this research. This is a drum boiler. This is a drum boiler. It is a standard feature of water tube boiler. The drum stores the steam generated in the water tubes and acts as a phase separator for the steam-water mixture. The experiment I have in mind is to find the most efficient algorithm to optimize the time of the operating sequence for the startup of a drum boiler. The startup of a drum boiler can be formulated as taking the system from an initial state to a goal state in a minimum time while satisfying a number of mechanical constraints. The initial state in the drum boiler at a certain point full of water, and the goal state is the drum boiler with a certain local pressure and steam mass outlet flow. This steam can be used in a thermal power plant, for example. To make the optimization of the drum boiler as efficient and effective as possible, 3 metaheuristic algorithms with 2 different initialization parameters were evaluated. To make the optimization of the drum boiler as an optimization problem, there are some influential variables to take in account. First, the simulation model. The fidelity of simulation model of the system is an important variable in the results obtained. If the simulation is not reliable, the results will be unuseful. For this project, the simulation model is based in a nonlinear physical model proposed by Astrom et al., and the simulation model is coded in Modelica language in the software OpenModelica. This simulation model is the one proposed by Belkir et al. Now, the solution representation. The representation of the operating procedure is an important variable. For this problem, the solution representation of the operating procedure can be defined as a finite vector with 3 discrete values each element, a tuple of operation and time, and a repetition element. There are 9 operations, with each operation being a combination of discrete values of each operable valve. The time element is discretized in values of 60, 120, and 180 seconds, and the repetition element in integer values between 0 and 9. The optimization algorithm to find the best operating procedure sequence. For this case, we will use metaheuristic algorithms, which has 2 important features, exploration and exploitation. Exploration means generating diverse solutions, usually by randomization, to explore the most possible the search space of solutions, while exploitation means focusing on the search in a local region when a good enough solution has been found there. The combination of these characteristics makes metaheuristic algorithms a suitable option to find a good solution in a reasonable amount of time for large-scale, non-deterministic optimization problems. Finally, the optimization algorithm parameters. The optimization parameters being the most important, the initial solution or seed. In other words, where do I start searching? For this research, I developed a metaheuristic hybrid optimization algorithm to perform the operating procedure synthesis of the drum boiler. This algorithm has the principal features of Kirkpatrick's simulated annealing and Glover's taboo search algorithms. The purpose of this study is to prove that the value of the startup time results between the hybrid simulated annealing and taboo search algorithms are not significantly different, but the hybrid algorithm is more efficient in the computational time than the simulated annealing and taboo search algorithm in the presented drum boiler case study. The experiment consists of the evaluation of two qualitative variable factors. The first factor will be the initial solution or seed, and its two possible levels are using as seed the solution reported by Bell here. Second, using as seed a randomly generated solution. And third, using as seed a feasible solution generated with a simple algorithm. This solution has bad time but is feasible. This factor will be used to determine if there is a substantial difference in the ability of each algorithm to generate a good result from a random solution and to determine whether it is useful for problems where there is a reference sequence. The second factor will be the algorithm, and its three possible levels are hybrid algorithm, simulated annealing algorithm, and taboo search algorithm. This factor serves to analyze the performance of each algorithm. The mean of 10 experiments will determine the outcome variable, and the simulation model and solution representation remains fixed. This experiment will be run using a computer interface. For this reason, there is not much concern about the appearance of disturbances in the experiment. However, the computer in which the experiments are carried out could be considered a covariate. It definitely affects the result, but it can be measured or controlled. For this reason, all the experiments were always carried out on the same machine. For this objective, I will use Taguchi orthogonal array, L9, which corresponds to three different seed scenarios and three different algorithms, and the reasons are that Taguchi's designs aimed to allow greater understanding of variation, and it presents a complete combination of the seeds and algorithms, which is required to prove the proposed hypothesis using a statistical test. These experiments will be conducted using a computer. For this reason, the use of the L9 array can be considered without representing an excessive cost for the project, even considering that each experiment represents 10 runs of each case. The following tables show the results obtained from the means and standard deviation of the 10 runs in each of the 10 experiments. Considering that 10 runs is a small population with normal behavior and different variances, a t-test was carried out to prove the desired statistical hypothesis. Here we can see the results in startup time measured in seconds and the results of computational time measured in minutes. With the mean and standard deviation of the results, the t-test was performed, which was able to verify or refute the proposed statistical hypothesis. The following table shows the results obtained. For the startup time case in red, in most cases, there is no significant difference in the result obtained with the hybrid algorithm compared to the result obtained with the taboo search algorithm and simulated annealing. However, for the case marked in bold, the average startup time with the taboo search was according to the t-test, significantly less than the average startup time obtained with the hybrid algorithm. This may have happened because taboo search algorithm performs many more simulations. In the case of computational time in green, according to the statistical t-test, the computational time of the hybrid algorithm is significantly less in all cases than the computational time of both algorithms, taboo search and simulated annealing. For this reason, the first hypothesis was refuted because there was one difference in the result obtained of a startup time, but the second hypothesis is confirmed because the computational time of the hybrid algorithm is always less than taboo search and simulated annealing. Thank you very much for your attention.